All right, so here's number 10. We have 3 terms, which means we want to start again with GCF. It looks like we will have a GCF for 28, 16, and 80. So for 28, you could divide this into 7 times 4, and 16 would be 4 times 4, and 80 would be 20 and 4. Is that the greatest common factor? Well, I think it would be, right? Because 7 and 4 and 20 then don't have a common factor. So your GCF here is going to be 4. But you also have n's in each one of these terms. So we're going to take the n with the lowest power, so n squared. So altogether, our GCF will be 4n squared. And let's see what would be left over. 28 divided by 4, that would be 7. N to the 4th divided by n squared, that would be n to the 2nd. So notice when I factor out, I'm just going to go through each term number by number, letter by letter. 16 divided by 4 would be positive 4. N to the 3rd divided by n squared would just be n. Negative 80, right? Make sure you're saying to yourself negative 80, right? It's not just 80. Each term is attached to the symbol in front of it. And now negative 80 n squared. Negative 80 divided by 4 would be negative 20, and n squared divided by n squared would cancel out, so you're left with this. So now let's look at this trinomial that we're left with, and it looks like we're going to have to use split the middle factoring. Let's go ahead and multiply a times c. 7 times negative 20, that'd be negative 140. And I believe we factored this earlier. So let me go grab the factor chart that we just had. Okay, so here's our factor chart for negative 140. And again, since this is negative, we want to choose factors who have a difference of, in this case, positive 4. So if you have a difference of positive 4, you're looking for factors that are very close, and you should look towards the bottom of your list, right? Far apart on the top, close on the bottom of the list. It looks like 10 and 14 would be our candidates, and we want this to add up to a positive 4, which means we actually want to do 14 minus the 10, right? We want the smaller number to be the negative one. 14 minus 10 gives us positive 4. So let's go ahead and split the middle, and just make sure we're careful in just bringing everything else down, right? We want to bring down the 4n squared, that was our GCF. 7n squared, that's our first term, and here we are, we're going to split the middle. We've got a negative 10n, and a plus 14n, and bring down the minus 20. We've now got 4 terms in the parentheses. Let's try to see what our GCF would be. Let's bring down 4n squared. These first 2 terms, 7n squared minus 10n, your GCF would just be n, because 7 and 10 don't have any common factors. So we'll be left with n times 7n minus 10. And then over here, for 14n minus 20, we have a common factor of 2. So if we take out a positive 2, we would be left with 7n minus 10. And don't forget, there's 2 layers of parentheses here. So our last step would be to rewrite everything here in the parentheses as 2 binomial factors. So the 4n squared keeps working its way down, and then we're going to get n plus 2 for one of the factors, and the stuff on the inside, 7n minus 10. And that's it. That is now completely factored. So earlier I did say that we know we're done factoring once each of our variables is down to the first power. Of course, there is an exception here if we're talking about a monomial that's out in front of your binomial factors, because that just simply can't be factored further. So when I said that, I really was referring to binomials or trinomial factors, not so much the monomial that might be in front. So this is indeed the end of the question, and that's how you would factor this one.